Hi, welcome back. For today's demonstration, we're going to talk about creating elevations for rooms and walls inside a link. Now we know that if I'm just going here and manually create this elevation, it will be looking at somewhere beyond the wall and looking at multiple levels, which is not ideal. Having to fix that every time to drag this and drag that. If only there's a way to create elevations automatically. Now, there are existing examples that does this. For example, a custom node where create elevations in room, or over here on this guy, Mr. Jeremy's website, there's a pretty elaborated demonstration on how to create multiple elevations by curve. But let's look at my solution to this example and talk about how I try to solve this. It's a little bit different from their solutions. So start by running this elevation by room in link. It's going to ask me to select the linked rooms. Go here, select the linked in the room, go finish, create elevations. See that it is creating 4 elevations per room. And in here, I can actually control the offset for on different sides of these elevations. So if I go here, when the room is rotated, run this again. This time I'm going to select more than just rooms, also the walls. It's going to filter out things that doesn't equals to room. And again, place an elevation marker in the room location and create these elevations. If I go to that, you see it's cropped between the levels. This is a level in another link, so it's between the levels I placed in this model. See that's a link over there, and these are the actual levels in the model. And even for rooms that are not square shape, we'll be able to deal with them just fine. It's going to create more than one elevation markers, but still it's going to create as few elevation markers as possible. And finally, there's another steps where I utilize this generic annotation. It's a simple annotation which intend to represent a elevation marker. I can turn them on by putting a number which is bigger than 0. I can turn them off by switching that to 0. So use this. I'll be able to place them in the view, looking at any location that I want to look at. And because it's annotation, I can easily switch them, tabbing space. So this time I have total control on where I want to place the elevation marker, and which wall I want to create. So over here, like that. So if I still run this elevation by room in link, for example, take this as the room. It's going to create 2 elevation markers. But if I run, so look at all the walls, but I don't really need to look at all the walls. I wanted to look at these walls. I go to run this elevation by annotation link. It's going to ask me to pick the link with room data. I have 2 links loaded in. And then it's going to read and find all these elevation markers and replace them with these elevations. So now I have made an intentional decision on where I want this marker to be and which of these views I wanted to look at. Okay, so this is the step, this is the demonstration. Now let's talk about how are these things created. So these 2 things are essentially very similar. We're going to use the elevation by room as the starting point to describe this process. So whenever I pick a room, the script will get the room boundary, which is a combination of lines, of walls in this example. And over here, there is a room separate line. So it collects these lines and also the room location. For example, if it is somewhere over here. Do that again. Okay, it's actually over here. Right. So it gets these informations. Now this room is a combination of 14 individual lines, but we only need 2 elevation markers and in total 7 elevations. So we need to group these lines. How do we group them? Well, we start by trying to find the perpendicular vector from the room location to this curve. How do we do that? Well, we take this curve. It could be going from here to there or going by the other way from here to there. So we extend the curve by a really long distance. And now we measure the distance from the room center to this curve. Now because we extend the curve really long, we're getting the perpendicular distance in this case. If we're using the old curve, we may be getting this distance because that's the shortest distance. Now we extend that very long, we're getting this distance. And now we have the point and the extended curve. We draw a line from the point and 90 degree to the vector of this curve. This is 6 feet, and then we draw some line more than 6. Let's draw 8 feet line. and we extend it in the other direction as well, 8 feet. So now I have an extended curve and a line which takes the room location as the center, and it's 90 degrees to this curve, and it's 8 feet on both sides, so it must have a intersecting point between this line and this line. So now we get the two curves, calculate the intersecting point. Now I have the room location and the intersect point. Therefore, we get the vectors. We draw a vector from the room location to that intersect point. Therefore, we get a vector. This is the step to get the vector. And if we do the same for all the other room curves in this example, it will be vector to that line and vector to this room curve will be extended and vector. This curve extend and vector. Similarly, vector for that curve. And vector for this curve. Vector over here. And vector over here. So on and so forth for all 14 of these curves. Now once we get all these vectors, notice how some of these vectors are having the angles between these vectors are 0, meaning that they are parallel room boundaries, and they're on one side of this room location point. For example, these 3 lines are parallel. Well, these 4 lines are parallel, but these 3 lines and their corresponding vector having a 0 angle, whereas this one, if we draw the vector, it will be over here. So it's actually 180 degree compared to these curves. Whereas if we draw the vector for that line, for this line over here, so these 3 vectors are 0 between each other, and these 2 curves are 0 between each other. So now we group them by vectors angle are zeros. We know that these curves are parallel with each other on the same side of the room location. We should be able to group them and creating less elevation views. How do we do that? We take the curves, we know the vectors, we take the longest vectors and move all the other curves by the distance equals to the longest vector minus their corresponding vectors. So we move those lines to the furthest end. And now I get a longer line. I group them to get a longer line. Similar over here. I'll be able to move this curve over there and that curve over there. and these are moved. So previously we have a room like that. Now we will be having a curve look something similar to this. No. This curve is moved over here and therefore joined with these lines to get a longer line. So it's 1, 2, 3, 4, 5, 6, 7 curves. They may not enclose to get a room, but it doesn't matter at that point. So we get these curves. Now group them by perpendicularity. So we take one of the curves, we take one of the line or curve, and get all the other curves which are perpendicular to them. So these 4 lines will be belonging to one elevation marker, and the other 3 lines belongs to the other elevation marker. Will be something like this. Therefore, we know we need 2 elevation markers and all the curves it needs to look at. And then the final step will be creating those elevations. We just pop in 2 of them, and for one of them we need actually 4 sides, and for the other one we need 3 sides, and then rotate them to match the curve. For the first one, in this case, we don't need to rotate them. For this one, we need to rotate them. Okay, actually it's rotating the elevation marker. I think it's 45 degree. Yeah, somewhere like that. After we rotate that, resize the curve so that it is looking at the correct location. You can see how hard this is to do it manually, which is more reason to do it using the script. Yeah, similar for the other one. The way to set the corp region, size the corp region. So if I go to like to add the corp, it will be like you get a 4 curves, a 4 side curves, something like that, and you just read the levels so that it will be like a little bit above the level and a little bit below the levels. In this case, level 4, something like that. And then on this side, we'll be taking this curve and essentially in the elevation draw something like that, where this line extend on both ends by the given distance, and the height of this curve is a little bit below the current level and a little bit above the level above it, which is all defined over here. The left and right offset, the top and bottom offset, and then there's finally the far clip offset equals to like how far you wanted that to be. Okay, so basically this is the step, and let's rerun this. You get one elevation marker with 3 views, and the other elevation marker with 4 views, where this one is looking at 1, 2, 3, and it's 2 feet to the furthest line of the furthest wall. This one is looking at 1, 2, 3 wall. It's 2 feet above, beyond the furthest elevation. And similar over here, it's looking at 1, 2. So on and so forth. And when it comes to the other one where you use the annotation markers, it doesn't use the room location for the placement of these markers. They use the annotations location to place the markers. And it doesn't create as many elevations as needed. It only check which of these is on. It read the parameters and only funnel through the curves, the vectors, which is like having a 0 angle to these curves, these vectors. So that's how this one is done. But the first step of processing the room boundaries are the same. If we look at the script a little bit more, this is the full extent of the script. This one is looking at only the walls over here, so I can easily do select the room and run. So you see that's taking the room location, taking the room boundaries, and this 14 lines. It's gonna, the first step, change them to straight lines, so that if you have a curved wall, it will process that as straight lines. And then extending the curves on both ends, measure the distance from the room location to the extended curve, draw a line that is perpendicular to the extended curve, and get the intersect and get the vectors. See if I preview that. Oh, this is doing that. Cool. And then group the vectors by the same directions. Notice I have a couple groups and a couple individual vector groups. Once we group them, we process that and eventually create a line through best fit. If I turn on that preview, notice how I get those lines being extended on the boundaries. Preview this, group them, preview that. This is the curve that we just draw over here. Will be like that. So it's this curve over here. We just draw that. It's over here. And once we get that curves, we take a couple lines and using this elevation marker, create elevation marker, and create elevation by marker index. This is from Rhythm. Yeah, the two nodes from Rhythm package. And once we create those views, again we calculate the marker's angle and then rotate the elevation marker, and then we get the crop curves to reset the curves, reset the far clip offset, and rename the views, etc., etc. But I think well, the more interesting topic is how to process the room boundaries so that we create the ideal amount of elevations for this room. And because if we do it this way, we'll need to delete elevations if we don't need them, and deleting is also like a painful process. In this case, you need to ask you whether you want delete every time. So I do the other step where create a generic annotation, and now I have a better control on where I place that. But in this case, you have to rotate that on your own. So it goes by space, so that is perpendicular to the curve. If, however, we're doing manual rotation, it might be off, and in this case, that one won't work. So there's gives and pros and cons. There's benefit and there's the manual process. You can't just have everything. Yeah, that will be all for today. Thank you.